Carbon fiber reinforced composites in F1 racing. Composites today are now used in most applications where lightweight, elasticity, and high strength are critical constraints. It's used in aircraft, buildings, and medical implants are just a few ways composite materials are changing the world around us. Carbon fiber is a fiber reinforced composite that can be made in many different ways. It involves the layering and direction of fibers that get either woven or unidirectional depending on the application. Epoxy is used to combine these layers and increase stiffness. The picture above shows all the parts in this plane that have carbon fiber reinforcements. Carbon fiber has useful mechanical properties that make it a better material to choose. Its strength, flexibility, and lightweight make it an ideal material for many applications, including F1 racing. The introduction of this material into the sport has not only made it faster, but also safer. Fibers hold loads along their length, which only gives stiffness and strength in one direction. When fibers are layered in different directions, it becomes strong from many points on different axes. When epoxy is used, it creates a polymer mixture that holds the fibers together but distributes the load and allows it to absorb heavier loads. Specifically, fiber reinforced composite materials like carbon fiber are making its way into the sport industry. We see it in sports equipment like bats, helmets, and even cleats. Its purpose is to remain lightweight and comfortable for the player while still remaining strong. F1 racing utilizes fiber reinforced composites to create their cars. The above photo shows the way carbon fiber can be shaped and molded to be more aerodynamic. The use of carbon fiber technology in the sport of F1 racing has opened doors to advancements in racing technology that allows drivers to be safer while being able to push their cars to their limits. Carbon fiber technology was first introduced in the early 1980s by the McLaren racing team. They molded the first carbon epoxy monocoque or cockpit in 1981. The monocoque bears most of the forces experienced during a race. Carbon fiber can be used in different parts of the car to improve its performance by reducing weight, increasing stiffness, as well as increasing a material's hardness. These parts benefit from carbon fiber's mechanical properties because of its abilities to have high stiffness with low density. Carbon fiber is able to be arranged in different patterns, so it is able to fit many different applications. Stress tests are used so that F1 race car materials can be examined and deemed safe enough for use on track. The vehicles must weigh enough to qualify because the sport has to put a minimum weight limit due to safety concerns. The above chart shows how the elastic modulus of fiber reinforced composites remain low while still being able to have a high strength. This is what the F1 teams were looking for when building their cars in order to protect the driver and withstand the forces and impacts the car experiences when racing. A puncture test is also performed to examine the fracture toughness of the side panels of the cars. This test was used in order to require teams to meet certain safety standards. Most injuries in F1 racing come from puncture damage from parts of their car or from their opponent's cars. The carbon fiber shells used on these cars were able to withstand greater impacts and remain stiff in a major accident. This picture shows how a front impact test would work. A sled with an indestructible face is attached by bungee cords that are stretched out. The sled is released and speeds down the track into the front of the monocoque to measure energy absorption, crushing, and deceleration. If the monocoque passes this test, it can then go into further manufacturing for the race teams to develop into their vehicles. Structure of the monocoque. The design of the monocoque or cockpit is meant to connect the front and rear suspension components as well as house the fuel cell and other steering components. The cockpit has a sandwich-like makeup with carbon fiber shells on either side like two pieces of bread, and an inside with a honeycomb-shaped alloy. The honeycomb-shaped alloy allows for the impact strength to be greater. This is a better close-up look of what the monocoque structure is made out of. It also gives us more information about the manufacturing process and how heat treatment can actually increase stiffness because of the resin layer. The carbon fiber parts you see on F1 cars are made from carbon fibers that are heated and carbonized, then heat treated and impregnated with epoxy so that the layers and direction of the fibers are held together, which creates a fiber matrix. Because of how it's made and its modulus of elasticity, carbon fiber is great for many applications. This picture shows the ability for this material to be molded into about anything. Because of its high tensile strength and modulus elasticity, it is great for making lightweight yet strong suspension components like shown in the picture below. These parts have to withstand immense amounts of pressure during an F1 race. Cost of carbon fiber composites. The cost of using carbon fiber over traditional metals is larger due to the process it takes to create composite metals of that scale. It starts with the base material, that is, fibers and resin for the epoxy. This may be both the most basic material form, fiber roving and liquid resin, or it may be pre-processed form of added values such as prepreg or woven cloth. Carbon fiber can be used in many different ways and processes once it is at this form, and once it's just carbon fiber and resin combined, it can be changed into many different things. The fibers come in rovings of filament and can vary in diameter. These rovings are then woven and pre-impregnated with a resin matrix. From there, it can go down many paths depending on the manufacturer and what they want. This chart shows a direct comparison between carbon fiber and steel. Clearly, the density is much lower and the tensile strength is much higher. This is because of the combination of those layered fibers and how it is able to withstand a higher load along the length of the fibers. This allows F1 teams to make areas of the vehicle much lighter and allow them to redistribute the weight into other areas when using carbon fiber over steel. And having the lightweight yet remaining the high strength allows the vehicle to reach much greater speeds, but also have a low center of gravity because they were able to redistribute the weight into different areas of the car, making it more stable and agile around corners.